Everyone, I welcome you back to Global Education Zone. And in this particular episode of Crash Mathematics for SS2 Senior Secondary School 2, now we are going to be talking about circle theorems. Now, before I begin this episode is strictly a revision episode because in the previous episodes of this channel, I've talked extensively and critically and in depth about circle theorems. I've given an in-depth classification and simplification, both examples and derivation of the theorems. So you can check out the videos of circle theorems, which I explain the concept in detail. So, but in this episode, we are just going to be doing a revision, and then I'll be solving one example to cap everything up. Now, there are basically 5 theorems we'll be talking about in this first version of circle theorems. So I will be doing another episode on the remaining theorems. Those are the tangential theorems, the theorems that deal with the tangent to a circle. But these ones are the basic 5 fundamental theorems. And the first is that a straight line drawn from the center of a circle that bisects a chord is at right angle to the chord. So anytime you draw a straight line from the center of a circle at right angle to a chord, it will always bisect the chord. And the converse is also true, because anytime a straight line from the center of a circle bisects a chord, that means it's at right angle to the chord. So you can just place the converse. They are both true. It's an equivalent statement. So that's the first theorem. Then the second one is that the angles obtained by the center of a circle the angles subtended by an arc of a circle at the center is twice the angles obtained by the same arc at the circumference. So what that means is that whenever an arc of a circle subtends an angle at the center, that angle at the center will be 2 times the angle at the circumference, simply. And then we have this second theorem is subtly displayed in another theorem, which you have angle in a semicircle is a right angle. That's the third one. So it is a sequel of the second theorem, because if the angle at the center is 180, then the angle at the circumference will be 90, because it's divided by 2. So that's why the angle at the semicircle is 90 degrees. So then we have the fourth theorem, which says that angles in the same segment of a circle are equal. So that is a very simple theorem. It also stems up from some other theorems, and it's very simple because one time you have a segment of a circle, the angles in those segments will be equal, because they are both subtended by the same arc. So anytime you subtend an angle at the circumference by the same arc, those angles subtended at the circumference will be equal. Next, we have finally the last theorem for today. We're dealing with opposite angles of a cyclic quadrilateral are supplementary. So the opposite angles of a cyclic quadrilateral, they will add up to 180 degrees. So what that means is that anytime you have angles in a circle and they are opposites in a quadrilateral, when you add them together, you get 180 degrees. And in the same time, there's another simple theorem that stems off from this, in that whenever you have the exterior angle of a cyclic quadrilateral to be equal to the opposite interior angle. So that is that, and those are the 5 theorems we've been talking about so far and I've been explaining so far. So let me give one example to cap everything up and to illustrate this in detail. So now this is a circle. In circle theorems, you basically deal with circle, but this time around, this will be a verbal work, a verbal exercise. So what we'll be dealing with in this part, let me draw a diagonal, the second diagonal. Then this will have this as 40. This will be an oral example. So this is, I will have this as T. We don't know what this is. I'll have this as S. I'll have this as B. I'll have this as U. I'll have this as R. And we'll have this as 10 degrees. Now, and we'll have this angle at center as Q. Now we are going to use our knowledge of circle theorems to see what we can do. Now we'll just apply any theorem in random, but these answers will be correct. Now if we have 40 here, so we can be guaranteed that the angle here also will be 40. So this view will also be 40. And the reason for that is that this angle here and this angle here, they are both angles in the same segment of a circle. They are equal. So if this is 40, let's have that down. Now if this angle here is 60, then this angle here will also be 60. U will be 60 because it is in the same segment. So U will be 60 degrees. So that was that. So next, let's see what other theorem can we form from here. So we can see that if this is 10, this will also be 10. So T will also be 10 degree. So T will be 10 degree. That's okay. That's okay. That's nice. So what other theorem can we form? So now look at this carefully. This angle and this angle, they are opposite angles of a cyclic quadrilateral. So if this is 60 and 10, which adds up to 70. So if one is 70, then the other will be 180 minus 70. That will be 110 degree. So this we have s plus 40. Let's set up an equation. S plus 40 equals 110 degree. So when we subtract 40 from both sides, we have 110 minus 40 equals s. So s equals 70 degree. So this s here has a value of 70 degree. So that's how we use the different theorems of a circle to get this value. So we've gotten these values, and what is remaining is r now. So we can simply say that because this angle here and this angle here, they are in the same segment, we can say this angle will also be 70. Because they are angles in the same segment of a circle. So you can see that by and by we have successfully looked for all the questions in this sections. And then this last one, this q at the center of the circle, I'll give it to you as an exercise. So what is the value of q? So let me give you a tip. Look at this shape. It forms a rectangle. So it forms a triangle, right? Look at this triangle. Now we are given two angles of a triangle, and we're looking for the third angle. So you agree with me that the sum of angles in a triangle is 180 degrees. So if we have one at 60 and the other at 40, what will the last be? So you can just subtract 180, subtract the sum of angles from 180 to get the missing angle. So as a quick tip, the answer would be 80 degrees. So you can also work it out to find out why. But that's all we have for this video, and thank you for watching. Don't forget to like, to share, and subscribe, so that's to encourage me to continue providing educational content like this. And you can give me your feedback in the comment sections of this video, so as I will know where to improve on these videos. And thank you for watching. See you in the next episode.